Okay, I set up a dashboard gauge here. I just put another cloth here so that we don't get to the ways, because we are slid that way quite a bit. I put a dashboard gauge on here, and I haven't touched off yet, so it doesn't matter if this is 0 or not. Until I do touch off, then I'll set 0. We said this earlier. We are 4 inches 791. So we're going to sneak up onto this. All right, we're going to touch off here. All right. We always set that, and we also set our dial down here. I just grabbed a little bit. I want to make sure that all the play is out in this one direction here. Now we're going to go ahead and we're going to take 10. That should bring us down to about 771. All right, and we're going to reduce our feed rate because we want to start working on a little finer finish here. All right, we're about 1/8 of an inch of hitting down in there. We're start hitting that relief area, and it's fading out slightly. All right, and it faded out, and we're right in there. I'm just going to go ahead and set 0 right there because I don't want to go in any farther. All right, now I'm just going to back her back out. It was nice that it didn't track back because we're doing a fine enough cut. It should be taking it. All right, let's see where we're at. We're at 4 inches 775, which is good. Pretty close. We had a coarse cut there, and we did the touch off and everything else, so we had a room to air, you know. Okay, so it looks like we got about 25 to 26 thousandths to take. It's about 12.5 per side. And like I said, I'm going to sneak up on it. So I'm going to take 5 now. All right, we're right down. We're getting down to nitty gritty here. This surface, I could use a. I think it looks a little better if I polish it up there. We're at about 6 over right now. 4 inches 756. So I'm going to go ahead and I'm going to take 5. No, I'm going to go ahead and I'm going to take 2,000 per side. I'm going to shoot for 4, and then I want to polish it a little bit and see, because I think I can get a thou or so a side polishing it there. Let's go ahead and we'll shoot for 2.5. Because I think it's going to be like 1 under. That's going to be a comfortable fit in that bore. All right, we're coming down into the root there. Okay, there's our 0. This time I'm bumping it in until I can see that root pretty well clear. Okay, that's almost right into the face. I like that. Okay, I'm backing out from both directions. see what we're left with. 751. That's really where I wanted to be. 750 and a half. A little tighter on my feel. 750 and a half. Okay, I'm going to put a little paper to that to see what it's going to look like. Now I'm just taking a smooth parallel here. Alright, we got 749 and a half. She feels pretty smooth.
Weight loss in writing.
Okay, let me go turn off the radio. Alright. Okay, haven't had that happen in a while. Alright, we're ready to get back onto our ring here, and we are set up to put in that little relief in the back here. And it's going to be about 20 thousandths on the depth. Alright, and we already came in, we touched our face, we set 0 on our dial, we showed all of that, and then all of a sudden we ran out of film or space on our memory card, the virtual memory of the machine. I transferred it onto a card, but the available memory put a damper, and it was just in the right spot. So without any further delay, let's go ahead and put that in there. And I believe I'm in the right direction, and we're a couple thousandths from being 0 to that face, and we're coming in touching, and we're 0 on our dial, and I am just going to be plunging in. There's 5. There's 10. Alright, now our sample shows that ring. Alright, I'm going to grab that ring. And my scale. Alright, and that's about 100 thousandths. 100 thousandths on the width. And we're about 60 here. Okay, that's about 100 there. And we're feeling that. And we're going to feel this one here, and this is probably twice or 3 times the depth there. It's just a by feel, by eyeball dimension I'm trying to put in here. It's just a relief. It's not nothing rides in this at all. It's there so that nothing will interfere with the face or the diameter in the root of that corner. All right, and give it another. Like I said, it was 20 thousandths deep, it felt like. So there's 19. And we're coming into our 0. There's our 0. Okay, we're just coming that last thousandth, and then we're going to feed it back out. That looks good. Okay, I'm backing out of here. Alright, I'm just going to take a piece of this paper here, and I'm just going to reach in here. Alright. Alright, I like that. Okay, we're done with all the turning here, in this face, and this face here. And so what we have left is this diameter here and the bore. And that, I'm going to measure in here. We got 350. Let's see if we can turn that now. I actually have almost 300 right there. Okay, 300, and it gets a radius turn on this outside out here. It's open to the air, so it's not a critical diameter. Okay, I've come in here and I've brought the tool bit and touched each one of my jaws at each one point and created a 0 and then backed off 20 thousandths, and that's going to be my 0 for coming in. And the first thing I want to do is go ahead and put a line there, so I physically have got a dimension or a position of travel to go to by eye to know that I'm getting close. And you see how that was lightly skipping right there? So by doing this maneuver right now, because I just mic'd this, and Mike is sitting here in front of me. I just mic'd this, and this is like 890, 91 or so. So we have about 16,000. That's all that's coming off of here. About 8 thousandths per side. Okay, so bringing it off here, we're going to come in and touch again. I'm only taking 5 right now because we're skipping, and I need to know a true diameter with a concentric cut, or a true running diameter is what I need to measure right now, and 5 thousandths ought to give that to me. I do have to give it some feed here. The reason why I put that mark there is because sometimes you might have a dial, a travel dial, or so you might have a piece of equipment, might have a chip in it, you might have something dragging, and if it's off by a little bit, you can probably see it before you get into the danger zone. I definitely do not want to skip my tool bit across the intersection of my jaws there, even though this top is not the location of the mating jaw. This lower surface right here is what your jaw contact makes, because this is a jaw, and then a jaw extension that bolts onto it, creates the whole jaw. Alright, let's go ahead and measure this now. Alright, and glad I just took that 5. We're reading 1 under. One and a half under. Alright, that's close enough. Alright, now we're set to go for the bore. Let me move my indicator and stuff out of the way, and we got to get set up for that. Alright, we got our bar down here ready to go on to the tool post, and I wanted this space. When the holder's locked down, the handle's in my way, and I wanted to set this right here, so I I had a good place to sit here and measure it up. And I'm reading about 1/1000ths under 3 7/8. 3/875. I'm reading about 3/874. And I'm gonna rotate this around a couple times, and I'm gonna check it high and down close to the gear. Same thing. Now there I'm getting almost 873.5, just under, maybe a couple tenths under 874. All right, now let's go ahead and measure. Go ahead and measure our bore we have here. And I've got an adjustment to do on the rod here. There we go. Okay, the inside mic and we're reading almost a couple over 3 3/4. So we got 3/752. So we got 1/8 of an inch come out of this bore. Okay, let's put our bar on here, and we're going to be changing around to forward directions here. And I think we're going to be keeping the same speed. Alright, first I'm going to go ahead and I'm going to bring you in so you got a little better shot of what's going right on with the tool bit here. And first I'm just bringing it in, and I'm just lightly touching right there. So I'm going to set my travel dial here at 0, and then I'm going to come inside here. Now I'm going to rotate this and just catch the skip in here, because it'll be running out the same amount that outside was just before we skipped it. I didn't put an indicator on it, but I know it is. Okay, now we know we have 1/8 of an inch, which is 1/16 on the side, and I'm just going to go ahead and I'm just taking 20/1000ths off of the side here from where we touched. Alright, I'm just adjusting my lighting here. There we go. Okay, we're 200 deep, and our part's total length is 1/700, 1/750. Now here we go. I'm just making sure that I'm going way past what I actually need. We're going to face the other side off after we pull it out of here. Okay, that's a full 2 inches in there. That's more than enough. All right. Now, I'm not really interested in blowing this dust around, so I'm sucking it out so that I can have a nice clean area to go ahead and put my mic in there. And looking for a rag. Here's one. And I like that feel. Alright, and it says 790, 793 and a half. And I'm getting 791 with this. This is 790.93 right now on that. So with this spacer and this extension on the small inside micrometer, I'm getting a couple thousandths discrepancy between, but that doesn't matter. I'm using this to mic the outside. It does about 2,000 smaller with this combination right here. All right. So we're going to come in here and we're going to take another 20. That's per side. So it's 40 coming out of there. Okay, we got about 47, so that's like 23 and a half per side. And I'm going to go ahead and I'm going to take 10. I want to see what it does on the fine. We are getting a little bit of back cut when we come in, and that's just characteristic of my carriage there and tool pressure probably with this insert here. And I went in and I put a dashboard gauge on here as well. Having a diameter of something like that, we come in as tight as we can, but it's barely fitting in there, and then we can hone it to size. This thing is made to clamp and create a break, but other than that, guide it through. So we want to make sure that we have minimum amount of clearance and still have a work sliding surface, and that's why we're doing this out of cast material here, because this is an alloy of steel, and this here riding on cast, which is a bearing material, and that's why we're using the cast or the ductile, either way you want to say. I mean, I grew up calling it cast iron, but there are different grades of cast iron which are ductile, and that's the phrase for it, the proper phrase. Alright, we're getting down to nitty gritty here. We only got one cut here left, and I just stuck this in here, and I'm just checking another spot here. It feels pretty good still. Well, it did feel pretty good. Nice soft pile of cast iron chips it fell in, but you never know if it rotates the thimble or anything, so don't even bother looking at it. Alright, I'm reading 873. And I'm almost reading 870 and a half here. Now we measured the outside of the hub, and we're reading that about 874. And we know we're gonna have to have a little clearance in there, but the way I see it right now, a 2/1000 cut will put it right in the ballpark. I'm just gonna check way down on the bore here. I want to see if I have a taper in my cut or whatever. I don't have the most perfect saddle. You always want to kind of check that. No, it's reading the same thing there. Yeah, I think I'm going to go for it. I'm going to go for the final cut. That's my final decision. Okay, there's the bottom. Okay, this time I'm not just dragging it back, I'm feeding it in so I don't leave a mark of pulling out from there. And let's grab the vacuum. Alright, and reading 2.5 over, and I'm reading 875 right there. You know, with a little luck, that might actually be able to fit right in there. Now I know I'm not going to cut anymore, so I'm going to, if anything's tight, I will sand, polish, and hone to get what I want out of here. Right now, I'm going to look, before I even try sticking this in here, this right here, there's a chamfer on the outside, but this is this is just a slight radius right here, almost like it's polished, and I think that's what I'm going to do. And it's not very much, but it definitely is not a sharp edge. Dust most of this off. I'm going to hit it with a little air in here just because I don't want any crumbs. I haven't done nothing to this. This is still clean and virgin. Let's just see. I like that. Why not? Okay. We'll be able to polish that, and that will definitely do the job we want it to do. Alright, one last thing that I got in here. Well, I got to break this corner here as well. But we have to put an angle on here. Looks like a 45. 45 by probably 93 thousandths, something like that. Okay, slow down our speed again before we forget about it. And I got my square here. All right, and that's 45. That looks comparable right there. This surface out here, it's kind of hard to tell. It's kind of hard to tell what that was. Okay, well, I want to break that edge back there, but I don't want to get in there too close to this. I'm just using the end of my parting tool, and I'm just going to barely break it just so it's not sharp. Okay, I like that. Well, that feels darn good. Okay, one last check, and that is just to make sure that we are still, still within a couple thousandths of here, and it's like 90, 92. 92. Here I was searching all over. Really kind of hard to tell because this thing was really hammered with it here. And we got like 86 there. $88. All right, we might be a little strong, but we can take a little bit of that. The 99 right here. I wanna be able to assemble the new ring in the part and see what we got for clearance on that bronze gear there, because that does set the thrust there. And putting that gear into the housing and then measuring down from the housing, I think I'm going to do that before I actually pull that out of there. And then I can verify that as another double check there. Because if we have to face some of this right now, everything is concentric. As soon as I take this out of here, I can't put it back in here and do anything to it, except for face off the other end. But I can't duplicate the accuracy that I have all those surfaces right now. That, the groove in there, this outside, the chamfer, everything is 100% concentric with each other right now. And that's all the working surfaces. This outside is to the air, and this really is to the air.